Melody, my diamonds that cold. Versace trunks, I hit my backstroke. Knock on the door. She at the back row.
Welcome back to Houdini is Hip. In the previous part, we looked at volumes and we looked at Pyro solving. So we took a look at how we can take our volumes or our geometry, and then we can scatter points into that, get attributes onto those points, and then convert those attributes into volumes. Of course, we had named volumes such as density and temperature, and we used them to perform certain operations inside of our solvers. So in this part, we're going to be taking that a step further, and we're going to actually be trying to create a bit of an effect. We're also going to be adding to the knowledge that we have, and then we're going to look at rendering. So the main focus of this is going to be the rendering part of it, but I want to show you how you can actually start to get really good looking effects with the knowledge that you already have. So let's go ahead straight into Houdini and let's begin on this project. All right, to start, we're going to drop a geometry node. We can just call this Pyro setup, dive inside. And over here, what we want to do is take a geometry, and then we're going to create smoke and we're going to create fire. We're also going to add some custom velocity to it so that it behaves in interesting ways. We're then going to cache that out to disk, and then we're going to render it using Karma. So the main idea is that I want a very thick, dense black smoke that's extremely turbulent, and then there should be small areas of high intensity fire, all right? So to do that, we're gonna need to do a few things, but we first need a geometry to work from. So let's go ahead and drop a rubber toy. And we just have this rubber toy over here. So we're going to use a Pyro source node, right? This is just one of the many ways that we can create a bunch of points from a geometry. And so as you can see, by default, it works on the surface. We don't want to do that. We want to do a volume scatter. So once we have that, we can also work on our particle separation. So we'll just do something like 0.05, right? We can go even lower with this, 0.2, until we're happy with what we have. The lower you go with this, the higher resolution you can go with your volume rasterized attributes, but the longer it'll take. So by default, it actually doesn't have any attributes on it. It actually does allow you to add attributes over here. For example, you could put in your density over here, and that would be perfectly fine. If you wanted to do it for something like velocity, you can even choose from a preset over here. It'll do V over there and set it as a vector. But this actually just defaults all the values to a single value. As you can see, it's just one in every direction. That's not actually what we want. Right, so we're going to remove velocity over there, and we're just going to use some attribute noises to generate our attributes. So at the moment, we just have P and P scale. I'll show you soon why we have P scale, and it'll make a bit more sense. So let's go ahead and use an attribute noise. This attribute noise, we can just rename to density underscore noise, just so that we know which one this is for, and set our display flag on it. We don't want a vector. Density is just a float. It is a single float value, not a vector. So we can go over here and just set this to density. And then we're going to enable our visualization. So just toggle it on. And as you can see, the cooler colors, or blue and dark blue, are going to be low values. And the warmer colors are going to be things like red. And those are going to be the higher values in your range. Let's firstly enable our remap ramp. We're going to drag the low end up a bit. That's just going to cut out some areas where we're going to have some zero values. Then we can bring the high end up so that we have some very dense areas. We also want to go ahead and just give this a bit of an animation. So we can animate the noise, switch on our real-time toggle. And if we play this back, you'll see that our noise evolves over time, right? So that's cool. The only other thing that we might want to do is maybe reduce the element size to something like 0.75. And then maybe add an offset to this. And I'll explain why we do offsets shortly. So now we have this one, and this is our density noise, right? It's generating a density attribute for us. And if we take a look at our geometry spreadsheet, we now have density, P, and P scale. Cool. So we've done all of this before. The next thing that we want to do is add a temperature to this. So we can click Alt and click and drag, and it'll duplicate our attribute over here. Now this one, we're going to rename to temperature underscore noise. And this one, of course, is going to be for our temperature. So over here, change the attribute name to temperature. And we're going to need a new visualizer for this one. So just click over here. And you may need to click on it like 3 times, because what happens is it needs to disable the old one, enable this one, and then all of that stuff. So to check if it's the right one, you can just right click on the visualization option in the bottom right of your viewport. And you'll see that temperature is enabled and density is disabled. So you can actually see how that works if you enable one or the other, right? Right now they look the same because they have the same noise pattern. So we're going to go over here and just drag up this low end. We want some very hot areas and then some areas where there's no temperature at all. Okay, so once we have that, we can decrease the element size very slightly to something like that. Now, this offset, the reason that we have offsets when we're working with different noise patterns is that technically the pattern is the same, right? And we can almost think of it like this is our temperature noise pattern and this is our density noise pattern. And if their offsets match, then the patterns are the same. So what we actually want to do is we want to sample a different position on the pattern, right? So what we do is we offset this one this way and maybe this one this way. And now they're two different patterns. So that's what we're doing when we're offsetting, right? Currently they both have 20, so they're both in the same position. We just want to offset one more than the other, so we can set this to like -20, right? So the ones move that way, the other ones move that way. So that's perfect. And that should be good, right? We now have a temperature that also evolves over time. If you want, you can speed it up by reducing the pulse duration. The pulse duration is just how long it takes for this noise to complete an animation pulse. Great, so we now have our two attributes, right? The middle mouse over here, we have density, P scale, temperature. So now that we have them on our points, we can go ahead and actually rasterize these with the rasterize attributes. Volume, rasterize attributes right over here. Plug this in and nothing will happen. So we have to choose which attributes we want to rasterize. So let's just say density to start with. And what you'll notice that's a bit different to when we worked with this before is that our particle scale seems to be working pretty okay. If you recall from before, it made a huge blobby mess. And that's because particle scale is actually multiplied by your p scale. So this p scale that's added over here is actually multiplied by your particle scale to give you the actual scale, right? So if p scale doesn't exist, then it'll just use this value. And we can actually see this if I just delete the p scale attribute. So I'm just going to do an attribute delete before this, and I'll just delete p scale. If I do that, then we have this big blobby mess. But what we have, because we have p scale, which is generated by our Pyro source, is that all of these points over here are scaled down by that p scale. So it's 1 times p scale. So that's pretty cool, right? I'm just going to press D over here and go over to background and set my color scheme to dark so that I can see my volume more clearly. Okay. We also want to increase the resolution of this. So this 0.1 over here, we can just decrease to 0.02. All right, so that's pretty high resolution. And if we just want to see how long it takes to calculate, we can just try playing this back. And this is evolving over time. So we know that this is a reasonable resolution to be working with, right? You don't really want it to be taking long on each frame. So something like this works pretty well. You can decrease the particle scale, but this is once again based on the Pyro source. So it's really giving you the best possible scale that it can. So, okay, that's looking good. We just want to add our temperature over here to the attributes that we want to bring in as well. Temperature, just like that. And always make sure that you're spelling them correctly. So now we have two volumes. The issue is that it becomes kind of hard to see what's going on, right? We actually have this very blocky looking volume, and that's because temperature isn't showing up the way that we want it to. So to actually change this, we're going to adjust the visible volumes and just set it to density. And this is something that you'll commonly do when visualizing your volumes, is that you'll hide everything except density, because density is usually also the volume that you're going to render. And another thing that you often do is that you mask one volume by your density. So temperature might only exist where your volume is, right? So what we do is when we have the visible volume set as density, it just allows us to single out density as our actual visualizer. One thing that I want to do before we send this into our simulation network is actually use a volume visualization node. This is going to be extremely useful the more you work inside of Houdini, right? So we're going to use a volume visualization node, and over here, as you can see, it uses the density as your density field. But if we go over to emission, it also looks for an emission field and an emission color field. In here, we can put our temperature into both of these. Temperature, and I'm horrible at spelling temperature, but temperature over there, temperature over there, and give this an emission scale. And as you push this up, you'll start to notice that we actually have what looks like fire. And that's because over here, it's using our temperature to give us a visualization of what that temperature volume actually looks like, right? So it's using density for this kind of smoky effect, and it's using temperature for that emission field. So now, remember when I said that sometimes you want to mask a particular volume by your density so that it appears in the correct way? This is a good example of it. So as you can see, we currently have this very blocky visualization, and that's because our emission field is set to temperature. But what happens if we actually just set this to density? As soon as we do that, you can see that the temperature is now clipped to the areas where there is density. And that's because we're saying the emission field is density, but use temperature over here to drive the color and the emission intensity of our density. That might sound a bit weird, but basically all we're saying is take out density, and only where there's density, then use temperature to drive the color, right? So that's what it ends up doing. And so it's pretty cool, right? You end up with that. So that's just a visualizer, a very useful thing to be able to use whenever you want to see what your volumes look like. We can just add a null over here, and this null will just be our sources out. So with our sources, we can go ahead and create a DOP network. So sometimes you will see that people go up to the object network or the object level, and they'll place their DOP net over here. You can do that. It's perfectly fine. You dive inside. It's the exact same thing. I'm going to do it once again inside of here, and we're just going to create a DOP net. And inside of this, we're going to be doing a bunch of things, but I'm just going to rename this to Pyro solver. Currently, it's just a generic solver, nothing going on inside. So we dive inside, and we need to place a bunch of things. I'm going to maximize this over here. You can do that by pressing Control B when hovering in a particular window, just so that you can see exactly what I'm doing. So we're going to start with a smoke object. Remember, the smoke object is what holds all of your information for the solver, right? So all of your data is stored in the object. We need a solver to run over the information that's in that object. So we drop a solver. And the solver that we need is a Pyro solver. We're going to be using just the regular Pyro solver and not the sparse solver. We will be looking at the sparse solver very soon. So go ahead and just use a Pyro solver, plug the smoke object into the Pyro solver into output, and then we need a volume source to actually source in some volumes. Right over there into the last input. If you hover over the inputs, you can see what they're asking for. So the first one is an object, the last one is a post solve or sourcing, right? So with this, we now have some options to bring in some of our volumes. We need to just choose the SOP path. And of course, that is going to be this over here where we just said sources out, right? Our sources out, that's the SOP path to look for. Over here, we need to add two operations. We need one for density and one for temperature. Those are the two things that we're going to be bringing in. So just add one over here. This one over here is going to be density. I'm just going to reduce this again. So Control B, back to this. So over here, we're going to firstly have our source volume for density. So density. The target field is also going to be density. And so this is always the name that you've created for it. If I had to call this something else, I could call this like smoke, but we have to ensure that it's matching the correct field when we bring it in. So this might be called smoke on our side. We might have named it smoke, but when it comes in, we want to say that smoke should go into the target field of density. We're just going to add another operation, and this one over here is going to be temperature. Temperature. This one, once again, temperature. Right? So it's just conveniently named. It just happens that the volumes that we're bringing in match the fields. And this is actually an interesting little thing to take note of. When we're looking at definitions and terminology and that, a volume is anything that's outside of a DOP network, so anything that's not part of a solver. As soon as a volume is part of a solver, it's called a field, right? So temperature, when it's outside of a solver, it's called a volume. But when we're using temperature inside of a solver, it's called a field, right? It's the temperature field. So whenever you see field, know that it is a volume that is within a solver. Okay, so we have temperature, and we're not going to be adding it every frame. We're just going to use the maximum. And all maximum is going to do is it's going to check, is the temperature that I'm trying to bring in higher than the temperature that's already in the simulation? If it is, use that. If it's not, use the one that's already in the simulation. So that's all it's doing, right? It's just taking the maximum value of the two and using that. So we have maximum over there. Now we can go ahead to our smoke object and just change its bounds very slightly. Because if we play this back, you'll see that our little cube fills up with smoke very quickly. So we're going to increase the size of this to just something like a 3.5 cubed space, right? Something like that. We can also move it up a bit. So move it up by 1 on the y-axis. Play this back, and it looks like everything fits quite nicely. We're going to reduce the division size. We're going to go 0.05. That's not exactly high res, but it should be high enough resolution for us to visualize this, right? Okay, so we just have that. Now, what we can do is immediately go over to OpenCL. So on our Pyro solver, go over to the Advanced tab and use OpenCL. This will use hardware acceleration to speed up your simulation, right? And it takes a little while for the simulation to start running, but it runs a lot faster once it does. So if you click start over there, you'll see it is a much, much faster simulation, right? So that's simulating pretty quickly. Now, all of this is great, right? We have some smoke that's coming off of our flippy over here, or our rubber toy, and it's lifting because we have a temperature. The only thing is that it's not very interesting, right? And we have this sort of pluming effect that we don't necessarily want. So that's often known as like mushrooming, and you can get around that in a bunch of different ways. You can add noise to your sourcing, or you can add things like disturbance and turbulence and velocity and all of that, and it will break it up when it's being emitted, right? So that's one way of doing it. So we're going to, of course, break that up. But there are a few things that I want to show you first. So firstly, I want to maintain these extremely hot spots of temperature, right? And then I want them to cool off very quickly. So to do that, we can increase our cooling rate. So 0.75 over here, we can push up to something like 0.9. All that's doing is that it's cooling down our temperature field very quickly. So the higher that value is, the more temperature is lost each frame. Also, temperature diffusion is an interesting one. Temperature diffusion is like a blurring factor for your temperature. So if your temperature is in a high concentration in one area, if your temperature diffusion is very high, it will diffuse into a big area around it very rapidly. The lower this is, the more contained that will be. So this will give you a sharper temperature. So if we decrease this to something like 0.2, then I'm getting closer to kind of what I want in my mind. And I'll get towards that effect as we go along. But this over here is going to be useful for that look. So now we can go over to shape. And firstly, we're going to add some disturbance, right? So let's take a look at what we have now. And as you can see, that disturbance has already made a massive difference. Now, this might be a bit much. It does look a bit too intense, so we can reduce it, right? We don't want so much disturbance, let's just do 0.1. And so you often need to just play around with your settings, but that's already starting to help our simulation along, right? There's some disturbance to this, and it doesn't look as uniform as it once did. We also want some turbulence. So if we switch on turbulence and play this back, it'll take a moment to start, but when it does, we'll have something like this, right? So again, that's looking kind of cool. Now, there's just a few more things that we're going to change. One of the things that I would really like over here is to actually introduce some velocity, right? And something that's kind of interesting is that we can go over to our smoke object and we can go over to the fields tab over here. And in here, it actually tells you all of the named fields that we have working inside of our solver. And as you can see at the top here, we have velocity and it's called vel, right? The same thing with like density, it's called density. The name in the brackets is what this is expected to be called when it's brought in, right? So just how we've been bringing in density and temperature, those are all the names of the fields that it's expecting. You can see there's a whole bunch, right? And I haven't gone over all of them, but these are the like main few, right? Velocity, density, temperature. You'll often see fuel and burn as well. We'll get into that a bit later. But for now, let's take a look at velocity or vel. So go up a level and let's add one more attribute noise. So I'm going to just tab attribute noise into the network. We can call this one velocity noise, and let's disable our visualizations, right? So we don't have any of that. Switch your display flag to this velocity noise. And over here, we're going to just change the vector name to v, lowercase v, for velocity. Okay, so to actually see our velocity, there's a couple of ways that we can do this. I'm just going to use the velocity trail over here. So on the right-hand side of your viewport, you can see display point trails. It automatically searches for that v attribute, and it'll give you point trails. So you can see which direction your velocity is moving in. If you take a look at this, it's all moving in the positive direction, right? And we don't actually want that. The reason it's doing that is because our range values are set to positive. For things like temperature and density, that's exactly what you want. You don't want a negative temperature or a negative density, right? So positive values are perfect. But in this case, we want some negative velocities, right? We want velocities that can go up or down, left or right, that kind of thing. So we're going to set it to 0 centered. That just allows it range in any direction. So now we have that. And if we just go ahead to the animation and add an animate noise, let's take a look at what that looks like. Right, so it's just this pattern that moves over time and evolves. And we can make this a bit more interesting if we decrease the pulse duration and decrease the element size so that it moves through a lot faster, right? So it's a more interesting noise pattern. Again, we're going to add an offset to our noise because we don't want it matching any of our other noises. So we're going to just set this to something like 40 because the other one was minus 20, 20, this one can be 40. All right, so on our rasterize attributes, we're also going to add V over here. Now, when we add v, you'll notice that it's called v over here, but it's not called vel, right? And so when we go into our Pyro solver over here, and we add another field using the operations, we need to ensure that this one is converted from v to vel. So first things first, we're going to change it to a vector from a scalar. Then we're going to set the source volume to v and the target field to vel, right? Something like that, super simple. Then we're just going to set this to a copy operation. So what that's going to do is instead of adding velocity into our simulation at each time step, it's going to just copy it from the source. So let's play this back and see what we have. So what you'll notice now is a sort of smoke that kind of plumes off in different directions, right? It's not so one directional where it goes up. It's now kind of pushing off in different directions. And so now we have a much more interesting smoke effect, right? And you can do all sorts of cool things with this. So on our smoke object, the only other thing that I want to do is decrease the division size to 0.03 or even lower, right? And this is because I want this one to be our final resolution. This is going to be the one that we're going to simulate and cache out to disk, and this is the one that we're going to render. So again, you can go even higher with this resolution. So 0.02, and now I'm going to save it to disk. We're going to use a DOP import, and you can actually use the DOP.io node. It's two nodes packed together, and it's pretty convenient, so we can use the DOP.io. With the DOP import field, this is where we need to choose the network that we want to fetch our simulation from. Then we choose the DOP node, which is going to be our object, because remember the object holds all of the data of the simulation. So for our DOP network, over here, we just go ahead and we choose our Pyro solver, and the DOP node is the object inside of that Pyro solver. So it's just the smoke object one, just like that. Now there are some presets which make this a lot easier for us. You can see that there's smoke, fire, all of these things. So we can choose Pyro, and it'll bring in density, velocity, and then a bunch of other things. We can remove the things that we don't need, like CD, fuel, heat, and the two rest attributes, right? So now we only have density, velocity, and temperature. As you can see, even here, it only shows density, right? Vel and temperature are set to invisible. And if we play this back, it'll actually fetch this from our simulation, right? So this is the data that we're fetching from our simulation. So let's say that we want to visualize this. We can once again use a volume visualize. So this is the exact same thing once again. And now it's cool because we can actually see what our simulation looks like when we start messing around with some of these settings. So emission field, we'll use density. And the temperature over here for the emission color. Increase the emission scale, something like that. And you can increase the smoke. So let's increase the density scale and the shadow scale. Something like that, right? And now you can start to see what we're getting at. And you can, of course, play around with all sorts of settings on here. But once again, this is just a visualizer. Okay, so we're going to save this to disk by clicking on this file cache node, just going up here to explicit. We're just going to set an explicit path. And what you can do is you can remove everything before the $f, right? So we're just going to give it a name. I'm going to call this pyro.out.f.bgeo.sc. Once again, I don't actually want to save out 240 frames, but it will do this by default. So if you actually click on where it says start, end, and increment, it'll tell you that it's going from the start frame to the end frame. It's using an expression to do that. You can, of course, change the range over here to 72. If I do that, you'll see that it works, right? So this actually fetches the frame range from our timeline. Or you can just right click on the start and increment thing and just say delete channels. That will remove that expression and you can put in a custom amount over here. So that's it, right? That's all we need to do. Then we can just say save to disk. I'm just going to let that save for a moment and then we can continue on. Okay, so once we have that, we can set our display flag on our file cache and it'll load pretty quickly, right? That's because it's coming directly from disk and it's no longer loading from our simulation. Another thing to take note of is that this blue bar over here no longer fills this entire range. And that's because our Pyro solver is only caching a certain amount of data to RAM. And when it runs out of data, it just moves the bar along. So all this is telling you is that these first 30 frames aren't actually cached anymore. It's saying that only from 31 to the end are actually cached in RAM. Everything has been saved to disk, but the Pyro solver is actually keeping these blue frames in RAM. And you can change the amount of RAM that's allowed for caching if you go over to the cache tab on any network. You can see over here, it says 5,000 megabytes are dedicated to caching. If you have a lot of RAM, you can set this up to like 64,000, so 64 gigs of RAM. That'll be nice because then you can, hold basically a massive simulation in your RAM and you can just kind of scroll through it without having to cache it to disk. Or you can disable caching entirely. There's an added benefit to disabling caching because what that allows is that you can save to disk. And if you are kind of limited on RAM, so if you only have, say, 32 gigs of RAM, each and every frame will get full access to that entire 32 gigs if you disable cache simulation, right? So keep that in mind. If you have a low RAM computer, you can disable caching, save to disk. It won't do any caching for you, but everything will be saved to disk and you'll be maximizing the amount that you can get out of your RAM. So that's just a nice little trick. If you don't have a very powerful computer, keep that in mind. Okay, so we now have this. A common thing that you'll see is for a Pyro bake node to be used. So I'm going to use it over here. It's partially visualization, but also partially practical. So I'm going to show you what it does over here. Pyro bake. We can plug our file cache into the Pyro bake, and you won't notice any difference. From here, you can do things like increasing the density scale, increasing the shadow density, and changing the smoke color, right? So maybe a dark smoke like that. And then you can go over to the fire tab and enable fire. It'll automatically use temperature to do this, right? And as you can see, that looks pretty cool. It's using our temperature to drive fire. And again, this is just for visualization purposes, but not entirely. So what happens is it actually creates a material in this matte location called Pyro shader. And that Pyro shader holds all of the settings that we use over here. So anything that we set over here gets held in that shader. We're not going to be using that shader because we're rendering with Karma. So we're actually just going to be ignoring that part of it and mostly using this for visualization. An interesting thing that you can do though is on the scatter tab over here is enable scatter. And I just want you to take a look at the volumes that you currently have in the Pyro bake volume. You have density, you have each component of velocity. Remember, it's a vector, so it's X, Y, and Z. And you have temperature. Now, I'm going to enable scatter, and then we're going to take a look at this again. You can see that there's now an extra volume called scatter. So what is that? Scatter is actually a color volume that gets added to the rest of our volumes. And what it adds is faked light scattering based on your fire, right? So based on the emission from the fire, it adds some sort of light scattering into the volume. It makes it look a lot more realistic, and a lot of the time, some people even don't use fire, they just use the scattering, right? So we're going to use fire plus the scattering over here. And of course, you can make all sorts of changes over here. You can even change the color of your scattering, right? So you can make it like a blue scatter or something. And I'm going to just leave it as orange for now, and we'll come back and mess around with colors in a little moment. Okay, so now we can use a null, and we can just output this as Pyro render. Cool, right? So we're sorted. We can go over to the stage level, and we can now use a SOP import to import our fire. So go over here to the Pyro render, pull that in, you'll have it right over here. I'm going to set up the camera in some interesting location, that. So add a camera, so now we have a camera as well. I'm going to go behind the smoke and just add a light over here, just to hit the edge of the smoke, so we can add an area light, and that will just add a bit of interest to our render. Go back to the camera view. We're now also going to add a Karma node, and we can just plug this into the Karma node, set our display flag on the Karma render settings, and let's just take a look at what we have, right? So currently it's just nothing really, right? It's using a default shader for all volumes. So it comes in not looking great. Okay, so let's just go ahead and actually switch this to the Solaris build, just like that. And once again, we'll just have to set the background to dark. So D, background, dark. Cool. We're going to click at the bottom over here just to bring up our scene graph tree, look through our camera. And as you can see, this is being brought in as SOP import 1 over there. That's not what we want. We just want to name this something like smoke. So now it gets brought in as something called smoke. We can create a material library, and we can create a shader for this. So dive inside the material library. We're going to be using an XPU Pyro preview. There's a bunch of different Pyro nodes. All of them do basically the same thing. They all just work in slightly different ways. And there's a bunch of tutorials on how to use all of them. We even have some tutorials on the channel about using Material X for volumes. But this one, we're going to use this one because it's super fast, and I can show you basically in real time what our smoke looks like. Okay, so we can just call this smoke or Pyro shader, whatever you want to call it. Jump up a level, autofill materials, assign it to a geometry. That's going to be assigned to /smoke. Now, the one thing that I want to do is go to our Karma render settings and actually switch this to the XPU engine. Because we're using the XPU Pyro preview, it runs extremely fast if we use it as XPU. So now we click on Karma render, and once again, we have smoke. And it does look slightly better. That's because we actually have a shader assigned. So now we can go to our material library and start playing around with these settings. First thing we're going to do is go over to our fire and give it an intensity scale. Let's try 100, and that's pretty intense, but we can also increase the density of our smoke and our shadow density. So let's push up our density scale to 10 and our shadow density to 10. So shadow density is how dark our shadows are. The general density is just how thick the smoke is, right? Again, we can actually give this a smoke color that's close to black, and that's going to do that for us. And then we can also decrease the scattering phase. The scattering phase is just kind of how much light scatters inside of the volume. That isn't including the actual light emission from the fire. It's external. So the light that we have behind the smoke, it's that. So that's actually just adjusting how much that light scatters inside of our volume. Okay, so we can decrease the intensity scale over here to something a bit more reasonable. And let's also enable the scatter. as you can see, we start to end up with something that's really interesting, right? So I can move around this and it all works basically in real time. Like this is rendering super, super fast. We can hide that grid over there. And that's what it looks like. So our smoke and our fire is now working, right? And you can make all sorts of changes to this. If you don't want such an intense scatter, you can reduce that. If you don't want such intense fire, you can reduce that. If you want more intense smoke, you can increase those, right? And you start to end up with some very interesting results. Now, the one thing that you should be careful of is that when you increase your density scale, you might end up with artifacts like that. So just work around with these settings until you find something that you're happy with. The only thing that I want to show you now is how we can actually fetch colors from our Pyro preview node and bring it into here, right? So what you can actually do is at your object level over here, so in your Pyro bake volume over here, we have this scatter node, right? And this is always going to bring in a color of orange. If we go over to our stage level and you take a look over here, you can see that fire has an option for color, but scatter doesn't. So what we can do is we can actually go over here and go over to our fire ramp over here. We can go copy parameter, paste relative reference over here. And now this ramp over here is actually just going to mimic whatever's happening in this fire color ramp over here. So if I change this to something like blue, you'll see that both of them change, right? The fire and the scatter. Then all you have to do is actually just take this color as well and copy it into your shader. So this color that we have at the end of our fire color ramp, we can once again copy parameter by right-clicking on it, then going over to our stage level, and inside of our Pyro shader, we can once again just paste this over here as a relative reference. So now the color over here is adjusting both our scatter and our fire color at the same time, right? Because it's working with our Pyro bake and it's working with our actual shader. So we can make changes now to this one over here and everything changes, right? So this is a pretty cool way of working because now everything's kind of just linked up very nicely. Again, I'm just going to reduce this a bit. As you can see, the scatter is doing most of the work. So we can reduce that, increase this, and you end up with some really cool results, right? So you can render this out if you want. The other thing that I just want to show you is something like a mask. You can do a mask over here. What that will do is it'll multiply your temperature by your actual density. And you can do this for scatter as well, so that it only appears in certain areas. And this actually has a bit of a range that you can work with. So the higher you push these values up, the more it will return to full effect. So you can just play around with these until you find values that you're happy with, right? So maybe something like that. Cool. Okay, so that's how you work with Pyro inside of Houdini. And this is going to get you a long way, right? This is most of the knowledge that you need for making really good Pyro simulations. And that's all there really is to it, right? We're going to be looking at a few other things. I'm also going to be showing you the presets at the end of this video. So stick around, this is going to be an extra part where I go through some of the presets and just explain what they do and how they work. It's going to be useful for you because then you can just take those presets and work with them. So that's it for this part in terms of rendering and everything. But do stick around for this little extra part at the end. This is going to go over some of the presets in a sort of quick run through, just to give you an idea of how they all work and how you can use them in your own projects. Okay, so just picking up from where we left off last, we're going to disable our Pyro setup over here. I'm just going to add another geo node, and we can just call this Pyro presets. We're going to dive inside over here, and if you type configure Pyro, you'll see that Houdini has a bunch of these things ready for us to just add, right? And these are really nice because they do a lot of the heavy lifting for us and all of the groundwork and things like that. Usually, I wouldn't recommend using shelf tools or presets like this for simulations because a lot of the time you can just get stuck in using them and never actually understanding how they work. But I sometimes use them because they do all of the boring stuff for you, like setting up sources and setting up the basic settings and that. So use these by all means, but understand what's going on beneath the hood. So I'm going to show you what's actually happening to these. And with the knowledge that we've gained from the last two parts, this should make a lot of sense to you. So let's go ahead and start with something basic, a billowy smoke, right? So you click it and it adds a set of nodes. It starts with a torus, right? As we always do, we just have a geometry. Then we Pyro source. So it converts it to a bunch of points and adds a few attributes to it, density and temperature. Now, what it does from there is just adds a velocity attribute using this attribute adjust vector velocity. And this isn't really anything you need to focus on too much. It's basically just creating that vector v and adding a noise to it, which is basically the same as using an attribute noise. It's just a different way of doing it. So as you can see, if we add our point trails, you can see that they all have a velocity over there. Then we rasterize those. So that rasterizes density, temperature, and v. That goes into this node over here. Now this might be interesting to you because I've just been showing you how to build a DOP network, but this one over here is different, right? It has all of the settings exposed over here. And that's because Houdini has been working on bringing all of their sort of DOP level things to the SOP level. So this is actually a SOP level solver. If we take a look at just the node on its own, it would be the Pyro solver, right? And this Pyro solver has everything. It has our sourcing over here. It has the different fields that we have. It has shaping options. They've moved some things around so that like buoyancy is now under the shaping options, which makes a lot of sense. And so they just do a bunch of things that make our life a lot easier. But what is this node actually? Because if you double click and go inside, it has this, right? And this isn't what we know of DOP networks. That's because it's actually hiding a bunch of stuff from you to make it easy, right? To make it manageable and digestible. But if you actually go up to this level and right click and then say allow editing of contents, you can dive inside and see that there's actually a lot going on. If we press Control F and then type DOPNet and double click on it over here, it'll actually take us to the DOPNet for this solver. If we dive inside of that, now you'll notice something that's maybe a bit familiar, right? We have a smoke object over here. We have a collider all the way on that side. We have a source volume over here. We have all of those things going into this Pyro solver over here. And then that is going into this where it's being merged together and then output, right? So this is actually just the DOPNet. There's a few extra things, but it's still got the object, it's still got the sourcing, and it's still got this Pyro solver over here. So back up at this level, it's doing all of those things behind the scenes, right? We don't need to worry about them. All of our settings are now at this level, but we now understand all of the different steps, right? We create all of these volumes based on attributes. We feed it into a solver. We now understand how to source things, what all of the sourcing settings do. We also understand the shape and all of those things, right? We now have a very good understanding of all of these settings. So if we play this back, you'll just end up with some billowy smoke. Nothing too crazy. It's all things that we've done before. It's got a Pyro bake so that it also creates a shader for us. The only other thing I want to show you is this over here. Under the setup, you'll notice that the simulation type is sparse. We've been working with dense simulations, and the main difference is that sparse evolves over time. It only occupies the voxels where data is needed. So what it allows is for much faster simulation. We have a very set bounding box, and all of the bounds of that simulation are simulated, right? They're all solved for. So there's a lot of empty space that gets solved for, and it's not very efficient. Sparse solving is more efficient. So by default, all of these solvers are set to sparse, so they will be a lot faster than what we've been working with. Let's go on to another one. So configure Pyro, and let's go over and create a bonfire, right? I just want to show you some of the other things. So again, this just creates this tube for us, creates a Pyro source, but this one has density, temperature, and burn. Burn is one of those other fields that I mentioned, and burn is basically just used for things that burn. So over time, something that's burning. And so they make adjustments to density, temperature, and burn. They rasterize this over here so that we just have this thin disk of density, temperature, burn, and velocity. That goes into the Pyro solver. If you play that back, you just have this fire that occurs over time, right? You have a Pyro look node to adjust the look of it. And then this on the right-hand side is a separate system. They have some points, they delete some of the points so it's not so dense. They use a density, and then they delete points based on that density. So if the density attribute is less than a certain amount, delete the points. It evolves over time. They give it a life attribute, a velocity attribute, they feed it into a popnet, and what you end up with are just these little puffs of embers. They use a particle trail node on it, so you end up with that. Merge that in with the actual fire, and you just end up with a fire that has some embers. And you can actually go back to our Spark tutorial and rebuild this kind of thing on your own, right? You don't actually need the shelf tools now. You understand every single step of this. You understand what's happening when we create our volumes, you understand what's happening in the solver, and you understand what's happening when we work with a popnet like this. The only other thing I'm going to show you is something like the spread. So configure spreading fire. This one over here, I'm only showing this one as a sort of standalone because it has a null that gets fed into everything, but this one doesn't actually work on its own, right? As it stands, it doesn't actually do anything. That's because it actually needs an input. What it does is it has these two things that are templated. This one on the left, this null, you can just plug a geometry into it. So you can plug something like a pig head into this, plug the pig head in over here. We have that pig head. Then we also have this hot region. This hot region over here is just this box, right? As you can see, it's that small box over there. We can move it around. And what it does is it puts a certain section or selection of points that are within that box into a hot region, and then it uses that to spread a fire over the surface. So if we increase its scale slightly, just like that, then we go over here, you can see that those points are actually added to a group, and those are the hot points to start with. It then does a little simulation to mimic the spread of fire over the surface, and then it rasterizes it to turn it into a volume. And if we play this back, you can see that the volume actually grows over time, right? It's because that source is spreading over time. And this is a nice little trick that they're doing, but really it's just the same stuff that we've been working with. The only other thing that you might not have seen is this collision source over on the side. What this does is it takes the pig head, converts it into a VDB and a geometry, and then merges them together to use as a collider, so that the fire and smoke never go inside the object. They're always just on the surface. So that's also, once again, just a nice little trick that you can do. That's just using the collision source node, this one over here. They merge both outputs together, put that into the Pyro solver, and you let that run for a bit, and you just have this fire that spreads over a surface over time. By default, it is very high resolution. I'm not sure why it's so high resolution. So you can decrease that. So you can increase the voxel scale, right? So 0.02, and that'll simulate a lot faster. And this is just to give you an idea of what's happening. Might be a bit difficult to see. Once again, you can press D in the viewport, change the background to dark, so that you can see where the fire is. And that's all it's really doing, right? So that's all. I just wanted to show you that even the tools that Houdini has built for you and all of these really complicated seeming networks, they're all really fundamentally the same thing, right? We just have some volumes being sourced into a solver. The solver has some settings for the shaping. That's it, right? It's nothing particularly complicated. As long as you understand that idea of taking attributes, converting them to volumes, putting them into a solver, and then adjusting the actual shape of your fire inside the solver, you're good. For now, that's all we're going to look at. Play around with these tools, play around with the other thing that we made, and get some renders going. You can tag us on Instagram if you'd like. That's at 9_between. That's all we're going through for this tutorial. In the next one, we're going to be combining RBD with Pyro so that we can do things like debris, right? We can do smoke on collision. So that's what we're looking at in the next part. Hope you enjoyed this. I'll see you next time. Bye.